Good morning. We have information about the project. Now we'll discuss issues related to the air distribution installation, ducts, pipes, and how to install it in the house. Is it better on the floor or on the ceiling? Or maybe there are other possible solutions? Once you have the project ready and move on to installing the system according to the design, the first basic rule when it comes to installing a ventilation system according to, for example, the recommendations of the Passive House Institute is to install the entire ventilation and heat recovery system, the ventilation unit, and the entire air distribution system, the ducts, within the warm zone of the building, meaning in the heated, insulated area. Any, let's call it, deviation or going outside this heated zone will result in the installation potentially operating with reduced efficiency and lower energy recovery performance, because there may be heat losses during the transfer of air between a given room, like, for example, the exhaust from the kitchen or bathroom and the ventilation unit, and vice versa, between the heat recovery unit and the supply air points. The task of ventilation. The task of the ventilation unit is to recover as much energy as possible. However, the ventilation unit itself does not generate heat. It does not produce energy. It simply recovers it from the air supplied to it. So, with a temperature of plus 20 degrees inside the building and an efficiency of, 90%, 85%, then the air entering the room might be 18.5 degrees, so the incoming air will be at a lower temperature than the air that's leaving, right? But to minimize this difference, to make the difference as small as possible between the exhaust air and the supply air, the installation needs to be properly designed and executed, meaning it should be within the warm, insulated, heated zone of the building. Here's an example of an installation diagram. So, the main collector ducts between the ventilation unit and the supply and exhaust distribution boxes, as well as the connections to the intake and exhaust grills, and also between the distribution boxes and the plenum boxes. This is how it might look, right? However, when it comes to the location and placement of the distribution or installation of a particular part of the system, whether it's supply or exhaust, we can organize and plan these parts so that, for example, the supply air can be distributed through the ceiling, the floor, or the supply can come from the wall, for instance, just above the floor or from below the ceiling. As for the exhaust air part, we need to plan it so that the exhaust points are located in the ceiling or on the wall as close to the ceiling as possible, about 15 to 20 centimeters away. This is because the cool air is supplied to that area. Why is that? Taking thermodynamics and its properties into account, it will sink downwards. Meanwhile, warm air, used air that already contains carbon dioxide and increased humidity, rises upwards, and that's where it should be collected and removed. How can we do that? When it comes to solutions for the floor, a very common approach used by architects is to have a layer of acoustic insulation, typically 5 centimeters thick, made of polystyrene installed on the floor to provide that acoustic insulation. So there we can hide the entire ventilation system, but based on ducts with a diameter of DN50. We also connect boxes of the same height to this system. However, a better solution is when we can use ducts with an external diameter of DN75 on the floor, as well as the entire system, meaning the plenum boxes or distribution boxes. This is because, taking into account the internal diameter and the possible nominal airflow, the difference is threefold. So, with a single 75 mm pipe, we can move as much air as with 350 mm pipes. That's why the optimal solution for use on the floor is to use the 75 system, and in the case of the 75 system, it's a good idea for the acoustic insulation to be at least 10 centimeters high. The first layer, which is 8 centimeters high, is used to level up to the height of the pipes. Meanwhile, the additional 2 centimeters on top will protect the pipe from, among other things, clips that hold the pipes for water heating, or alternative solutions replacing styrofoam, such as foam concrete, styroconcrete, or other so-called liquid solutions, which also have acoustic properties. They are better because, in fact, they coat or pour over and level out the entire installation for us. And as I said, the main purpose of this acoustic insulation is primarily to protect rooms from the transmission of sound between floors, but also to provide proper, even filling and a level base for other installations, such as underfloor heating or water heating. This is, among other things, what it can look like when using 50mm pipes, where, in order to achieve the right efficiency and the right amount of airflow, we have to use a lot of these pipes, and sometimes there just isn't enough space in the area we want to use for air distribution. And as I mentioned, we can also supply air from the floor by using, among other things, slot diffusers mounted in angled boxes for slot diffusers, located, for example, under glazed areas like balcony doors or any other glazing. Right? The 75 system. There are fewer of these pipes now, yes, but again, they have a greater height. And here too, a good solution is to properly plan the installation so that there are no clashes with other systems, like the water installation or the electrical installation, because if the rule of first come, first served is applied, it may turn out that in those 10 centimeters of acoustic insulation, there won't be enough height. And I've seen photos where, for example, the top of the pipe was already sticking out of the insulation, or, for instance, out of the poured concrete, right? Or out of the flooring. So it's better to plan this properly in advance, to anticipate things so that the installations avoid each other. And if they do have to cross at the same height, then, for example, you could make a notch in one, or change the diameter, or adjust the height. The second solution is to install it under the ceiling, or in the space of the suspended ceiling, or the whole system is mounted to the underside of the ceiling, right? This is a convenient solution because usually the height of the suspended ceiling is 8 to 12 centimeters, so in reality, we can fit installations there that even use pipes with a diameter of 90 millimeters, right? Here, you should use plenum boxes that are smooth and flat on the top side, compared to what we use in the case of a floor solution, where that flat part is on the bottom, right? And also, it's often used and possible to install the system in the space of a suspended ceiling, but for example, on the top floor, where we're dealing with a layer of insulation. And here, the most important thing to remember and take in is to install the pipe system, the air distribution system, in such a way that all the insulation planned for this part of the ceiling is above the pipes, above the ventilation ducts. Not halfway, not in just some part. If it so happens that we have to hide the pipes within this layer of insulation, then it should be arranged or planned so that the minimum thickness of the insulation is measured from the top of the pipe. Not from the bottom, but from the top. This way, we ensure proper installation and also reduce issues related to thermal bridges, meaning heat loss during transmission. So, taking this into account, the most important information is that the entire ventilation system, pipes and ducts, should be installed beneath the insulation layer, which is the element that keeps the heat inside the building. Sometimes, for example, a concrete ceiling is built, and only then is the insulation layer, like mineral wool, styrofoam, or something else added on top. In that case, the ventilation system can also be installed from above, because the insulation is above the pipes. However, in this situation, you need to add the thickness of the insulation to match the thickness of the duct. Examples and possibilities include how you can run the system in the space of a suspended ceiling using extension pieces for plenum boxes, or, for instance, you could install a floor box. This might sound odd as a ceiling solution, but with an inlet for the spigot under the air diffuser, using a socket spigot, where the frame spigot of the air diffuser fits into the socket of the spigot of the plenum box. But that's in a solution like the one we have shown here, where the box is mounted to the structure, to the frame of the suspended ceiling. The next part of the course will show you where and how to install the remaining components of the system, such as the air intake, exhaust, heat recovery unit, or, for example, an anti-smog box.